Welcome to today's lesson. In this first tutorial, we will simplify the powers of I. So we're in section 4.6 and we're introducing our complex numbers. It actually was not until the year 1545 that mathematicians finally got fed up with this equation, x squared equals -1, or similar equations, because there was no number that we knew that when we squared it would equal a negative number. So mathematicians decided to create a new number system called the imaginary numbers. If we take our equation x squared equals to -1 and we solve this equation, of course we would be taking the square root of both sides. So the square root of x squared becomes x, and the square root of -1 is the value that we're talking about right now. Now technically it would be plus or minus, but let's just take the positive square root of -1. This is not a real number. They decided to call this number that is not any number that they knew before, they decided to call it I. I is the first number that when you square it equals a negative number. So we have that I is equal to the square root of -1, and therefore I squared would be equal to -1. It's important to understand this relationship. Two other points I want to make. I is not a variable. I understand that it is a letter. That's the letter I, but in math we call it a number. It's the first imaginary number. It's representing the square root of -1. It is not a variable. And I, of course, is not a real number. It's the first of our imaginary numbers. So when we're first looking at our radicals, if you ever see the square root of a negative number, you have to understand that that is not a real number. It is imaginary. And what we need to do first is whenever we have a negative underneath the square root, we need to pull it out. If we have the square root of -a, that will be equal to the square root of -1 times the square root of +a, which in turn equals, since the square root of -1 is I, becomes I times the square root of a. What we need to do is pull out the I. That's not what I meant to write. Not our I. Pull out the I. Okay, so that's what I always think about. Whenever I see a negative underneath a square root, I pull that -1 out as the square root of -1, and then there's an I attached outside to our radical. So for example, if we have the square root of -25, the first thing I need to do is pull this square root of -1 out. I know that that's equal to I, and then I will have the square root of 25 underneath. The square root of 25 now is a real number, and I can simplify that in ways that I've learned before. Of course, the square root of 25, it's a perfect square, and that's 5. So I'm going to write this answer as 5i. 5i is another imaginary number. The second example, again, I've got the square root of a negative, so that's no good. The first thing I'm going to do is pull out that square root of -1 and write it as an I outside, and then I've got the square root of 45. Square root of 45 is a real number, and I can deal with that in ways that I've dealt with before. Now, 45 is not a perfect square, so I do have to split this up into what the perfect square factor would be. I'm going to leave that I out there. 45, of course, is 9 times 5, so I'm going to write the square root of 45 as the square root of 9 times the square root of 5, because the square root of 9 is 3. I'm going to pull the 3, and then the I, and then the square root of 5. And that would be the simplified version of the square root of -45. Remember, our first step will always be pulling out our I. If we see two radicals together, I cannot multiply them until the I has been pulled out of each. So this becomes I times the square root of 5, and this becomes I times the square root of 40. And now that I have the real numbers, at least the square roots are real numbers, now I can multiply. Well, if I have an I on the outside and another I on the outside, I times I becomes I squared. And then I have a 5 and a 40 on the inside. 5 times 40, of course, is 200, but that is still underneath a radical. So now I have I squared times the square root of 200. Well, I squared, we all know, is negative 1. So this becomes a negative 1. And then the square root of 200, I'm going to split that up into, it's not a perfect square, but I know 100 goes in there. So I'll split it up into 100 times 2. Negative square root of 100 is 10. Square root of 2, of course, is still 2. So this is some beginning things with our complex numbers. Pull out your square root of negative 1 first, and then simplify your radicals as you've learned in a previous class, Algebra 1, and you learned some in geometry. What I'd like to focus on in this tutorial is the powers of I. So we know that I is equal to the square root of negative 1. So sure, that's great. Ultimately, that's just equal to I. When you see I, that's just equal to I. I squared, we know that that's equal to negative 1. I cubed would be I times I times I. Well, if you know that I squared is negative 1 and I is I, then I squared times I, which is I cubed, would be equal to negative I. And lastly, I to the fourth, we know that that could be written as I squared times I squared. And if I squared is negative 1 times negative 1, then this is negative 1 times negative 1, which is 1. So we've got I, and then negative 1, and then negative I, and then 1. And this pattern repeats itself every 4 times. I to the fourth is equal to 1, so we could rewrite I to the fifth as I to the fourth times I. Well, I to the fourth is a 1, so 1 times I would just go back to I. I to the sixth we could rewrite as I to the fourth times I squared. I to the fourth again just cancels out to be a 1, so I to the sixth is basically the same thing as I squared. And I squared is negative 1, so this is equal to negative 1. I to the seventh we could break up into I to the fourth times I cubed. Again, the I to the fourth is just equal to 1. So this ultimately I to the seventh is equal to I cubed, and I cubed is negative I. And finally, I to the eighth, I could write it as I to the fourth times I to the fourth, which would be 1 times another 1, which is 1. And here is our pattern that repeats every single time, every fourth time. I, negative 1, negative I, 1. In other words, or in other ways, it goes from an imaginary to a real to an imaginary to a real. Positive to negative to negative to positive. There are a bunch of different patterns here, but ultimately you need to memorize I, negative 1, negative I, 1. If we look at the next 4, we've got I to the 9th, we've got I to the 10th, we've got I to the 11th, and I to the 12th. I to the 9th would be equal to I to the 10th is equal to negative 1, I to the 11th is equal to negative I, and I to the 12th is equal to 1. There's our pattern again. Now these exponents can get larger and larger, so there are some things that we could do to figure this out. Since our pattern happens every fourth time, what we could do is take our exponent and divide by 4. We're going to take our exponent and divide by 4. Divide exponent by 4. And when we do that, again, because the pattern is every fourth, when we do that, we're going to get some decimals. If we divide by 4 and we get a decimal of 0.25, that means that there's 1/4 left over, and that would be equal to I. If we get a decimal of 0.5, that's 2/4, and that must mean that ultimately we're talking about I squared, an extra 2 i's, which would be negative 1. If we divide our exponent by 4 and we get a decimal of 0.75, that's 3/4, and then we're in the I cubed slot, which is negative I. And if we divide our exponent by 4 and we don't get we don't get a decimal, it goes in evenly because 12 is divisible by 4, 8 is divisible by 4, 4 is divisible by 4. We will have no decimal, and that would be our fourth one, which is equal to 1. So here's how we could look at it on our calculator. So if we have a bigger exponent, let's say I to the 13th, well, I to the 13th is not too bad. Since I've already listed the first 12, we know that I to the 13th is going to be the very next one of the next set of 4, so we know that that's equal to I. So that's not too bad. I to the 102, okay, that number is a little bit bigger. So we could take our calculator, and we could take the exponent 102, divide it by 4 because it's a pattern of 4, and see what our decimal is. And our decimal is 0.5. If our decimal is 0.5, then we're going to be equal to -1, and that's it. So this is going to be equal to -1. Now, if you're not using the calculator, what I see the biggest number in our exponent that's divisible by 4. I see I to the 102, and I break that into I to the 100 because I know 100 is divisible by 4. And then there's an extra I squared. I to the 100, since it's divisible by 4, that's basically a 1 times a 1 times a 1 times a 1 times a 1, 25 ones. And 1 times itself 25 times is ultimately just 1. So it leaves this extra I squared, and I squared is equal to -1. That's how I'm ultimately figuring it out. But if you need to use a calculator, that's absolutely fine with me. So we look at this one, I to the 43rd. And we look at this one, I to the 4092. I'd like for you to do these 2 tries by yourself. Use your calculator or use your pattern of 4s and figure out those. Pause now, and I'll come back and check the answers. Please pause. Try them yourself. Pause now. Thanks for pausing and trying these by yourself. For try 1, you should have gotten that equal to -I, and for try 2, you should have had that equal to 1. So there's not much work that you can show for these unless you want to do something like this. It might just be in the calculator or in your head. Thanks for watching this tutorial on the powers of I, and I'll see you in the next tutorial.